Okay, let's have an example of a memory leak with an unowned reference. So, um, um, let's talk about retained cycles, memory leaks, and the overlap because they're slightly different, but they both come to the same thing. So, a retained cycle occurs when you have two or more objects that hold strong references to each other, preventing their reference count from dropping to zero. Because of this, the object cannot be deallocated, even when they are no longer needed. And I showed you an example of a retained cycle earlier. Um, we're going to do another retained cycle. In the example, if a strong reference B via B and B are strongly referencing A via A, you have a retained cycle. This retained cycle keeps both objects in memory even when you set the variables to nil because their reference count never reached zero. Memory leak. A memory leak occurs when memory that is no longer needed is not released. A retained cycle is one common cause of memory leaks because objects involved in the cycle are effectively orphaned and cannot be accessed or used, but they still occupy memory. All retained cycles result in memory leaks because objects involved are stuck in memory. Not all memory leaks are caused by retained cycles. Memory leaks can also occur due to improperly managed memory. Forgetting to release manually allocated resources in low level code. So, now an explanation in this, in the code I'm about to show you, unowned reference B holds an unowned reference, B holds an unowned reference to A, meaning that it doesn't retain A. If A is deallocated, the unknown reference in B becomes invalid. No retain cycle. Okay. A holds a strong reference to B via B. B holds a non-retaining unknown reference to A. Proper cleanup, when you set A equal to nil, A is deallocated. Okay. Since A is the only strong owner of B, B is deallocated. Using unowned works here because A will always outlive B. If this guarantee isn't true, you must use weak instead to avoid crashes. So again, let me rephrase something I said. I said this is a retained cycle. It is not. It is just a strong reference. And but it is an example of an uh, unowned property, right? So an unowned property is a property that's never supposed to be nil. It's always supposed to have a value. Okay. Unlike the weak vars can sometimes be nil when the object is initialized, right? And when you set it, then you potentially have a strong reference unless you explicitly make it weak. Okay. But unowned are different. They always have a value. And I'm going to show you what I mean when I say they always have a value. So now we have class A with a property B of type B, optional. And we're using our deinit block to let us know that this class is deallocated when it's not being used, right? Once it's outlived its uh its task, okay? So that means that as soon as it does what it does, then it's outlived its task, then it should be deallocated. Then we have class B, right? And it has a property A of type A. Okay. Actually, this is a circular reference. Um, this is a potential retain cycle. But class A, this right here could possibly be nil. This, since an initializer sets it, once it is initialized, this will always have a value. So you have A, but then when you initialize it and you create it, the instance of it, you must set A explicitly. A is a dependency. Okay, you set it. And then, of course, once it's finished doing whatever its purpose, it should be released from memory. It's out, its lifespan is up. Okay. So we created A, right? A could possibly be nil. So there we go. A with nothing passed to it because it's nil. Okay. However, we set the B property, right? We set the B property, and we set the, I'm sorry, we have the B value is of type B, and its value, we set it to an instance. We create an instance of B, which means we need A. We must pass A to it, right? That's part of the definition. And we pass this value of A to this. Boom. Okay. And now, when we want to set A, right? We want to set A. We have A, the B value of A set to B. Okay. So now we have this circular reference. Let's see what happens when we try to set it to nil. As you can see, it didn't deallocate. It didn't deallocate. So this is where an unowned reference comes in. This always has a value. Okay. This is the child in this situation. Okay. Why? Because its initial value is dependent on this. Okay. This is the child. Its initial, this is dependent on the existence of this, period. And so, since we have this right here, we want to release the resources from memory and get rid of this memory leak. What we have to do is we have to make this unowned. Unowned. Okay. And then we set these to nil, and A and B are deallocated. So again, you need to take this code, it's downloadable from this course, and kind of run it through your mind. Okay. Um, and I think I'm gonna explain this one more time. So let's understand the parent-child relationship in memory management. Okay. And we're gonna apply it to this unowned uh the situation with the unowned property. So we're going to try and see what the difference is between the parent object and the child object. A parent object is an object that owns or governs the life cycle of another object, the child. The parent is responsible for creating, managing, and ultimately deallocating the child. It holds a strong reference to the child. The child depends on the parent for its existence. It assumes that the parent will always exist while it is alive. The child does not own the parent and typically holds a weak or unowned reference to it. Now, let's go back to the code. So let's look at this code again, okay? We need to decide which one is the child. Of course, now we know that B is the child, of course, because we made it the unowned property. But why? Specifically, I'll tell you why. When we created B, right? And there are references here, A and B. When we created B and set a value, set A dot B equal to B, but guess what? A was never dependent on B. Remember, one has to be dependent on the other for its life cycle. A can outlive B. I mean, B can outlive. A is responsible for B. It is the parent child, it is the parent object in this property. B cannot exist without A. B has to be set with A. A has to be the parent. It holds the strong reference to B as a result. And so, if A holds a strong reference, the child must be either the child property, where A is used, must be either weak or unowned. Since um, A can never be nil, it doesn't have the option. It's not, first of all, it's not optional. Number one. Number two, it's set in the constructor. It will never be optional or nil. So it must be unowned as opposed to weak. And that's why that is the logic. Again, you need to take the code, look at it, play with it, watch this video over and over again because to tell the truth, um, when I started in iOS mobile development, a lot of explanations didn't make sense to me. And I'm trying to make this crystal clear because it took me a long time to get this crystal clear in my mind. So, yes, on to the next.